Chapter 3, Fire Alarm System Components and Functions. Your objectives for this chapter. Describe a fire alarm system. List 5 functions fire alarm systems provide. List and describe the 3 types of fire alarm singles. Discuss the characteristics of conventional fire alarm system technology. Discuss the characteristics of addressable fire alarm system technology. Discuss the functions of a fire alarm control panel and Annunciation Panel. List and describe the different components that make up a fire alarm system. List and describe devices that interface with the fire alarm system to supervise the conditions of the fire protection systems. Fire alarm systems provide notifications of fire emergency and are critical to the chances of survival. Surviving a structure fire depends on the amount of time from the first start to recognition of the fire and evacuation. Many buildings, based on their group and occupancy conditions, require some type of fire alarm system to enhance life safety and, of course, protect property. The fire alarm system has 3 major components that we're going to talk about. First being the initiation device, 2, notification devices, and 3, the control panel or the brain. Many of the sophisticated systems not only send a signal to notify occupants, but they also send a signal to notify people who monitor the fire alarm system, who are trained, of course, and they're off-site. Many times this is a third party or a private company that monitors the system. However, there are some alarm systems that are directly hardwired into your local 911 service area. They also may send a signal to other fire and life safety systems to initiate other life safety functions, such as capturing elevators, unlocking exit doors, maybe starting fans, closing smoke dampers, and pressurizing stairwells and towers and elevator shafts, so smoke doors, of course, will close and cause places within the structure that are free of smoke so individuals can appropriately evacuate. Many different components ensure systems functionality and operational capability. Some systems only perform a few basic tasks while others have multiple interconnected components in terms of alerting and notifying and activating other life safety functions. All components have a place and a purpose and must be evaluated and tested by approved individuals. These systems should also be tested and approved by UL, Underwriters Laboratory, or FM, as FM Global, as these private organizations certify and ensure that the systems are up to snuff and capable of doing what they claim they're supposed to do. Okay, let's talk about the control panel, also known as the brain. Many of the older fire alarm control panels use conventional technology to link manual fire alarm boxes and bells to provide code or non-coded alarm signals for evacuation. The earliest designs used 2 wire circuits to establish initiating devices and notification of applicable zones. Unfortunately, a break in a wire could render any device beyond the break inoperable. Many of these panels are still in service today. As long as they are checked out annually, tested, and maintained, they can still stay in service. Unfortunately, as the technology gets older and older, the manufacturers make it increasingly difficult to get replacement parts and certified technicians to test these older devices. The next generation panels featured modular equipment with smaller electrical components, logic or circuit relays, 2- and 4-wire circuits to support the initiating devices, and expanded performance and system monitoring. The 4-wire systems are more reliable because they allow for 2 wires to power the device and 2 to initiate the alarm. In other wiring configurations, a break in 1-wire device failure would disable the device. As with this 4-wire system, one break will not disable the entire device. Again, many of these panels are still in operation, but installation is less common with the new and ever-changing technology that comes to fruition on a daily basis. Today's panels use state-of-the-art electronics, microprocessors, and intelligent software that provide specific information about the device, identification, and alarm location and type. Commonly referred to as addressable technology, intelligent technology, or multiplex technology. This technology supports all sizes of fire alarm systems and makes information available immediately to first responders, inspectors, and service technicians as to the point and origin of a fire or trouble in the system. How these systems work. These panels have multiple functions. They monitor the integrity of the system circuits and devices, process manual and automatic input signals from initiating devices. They provide an interface to control or activate other fire protection and building systems. They provide power supply to support all systems and devices. They should have 2 independent sources of power. The main source is usually powered by a utility. The old systems used 120 volt alternating current, or VAC. The modern panels convert voltage to 24 volt direct current, or DC current, through the power supply circuitry. The backup power sources is rechargeable. The storage batteries or an engine drive generator should be present. Storage batteries must be able to sustain power for 24 hours in normal ready mode and 5 minutes in full alarm mode at the end of the 24-hour period. These requirements are different for voice alarm communication systems and mass notification systems. If a generator is used, it must have 4 hours of battery capacity. Through constant monitoring, the fire alarm control panel initiates appropriate signals to evacuate a building, investigate a problem within the system, or investigate a condition outside the normal operating parameters. Types of fire alarm signals. Not all audible and visible information communicated by a fire alarm system means there is a fire. A signal can sound to indicate system integrity problems or indicate that the normal operating parameters of the system have changed. Alarm signals alert occupants to a fire and emergency. The signal sounds once a manual or automatic initiation device operates. For example, a manual fire alarm box, smoke detector, or water flow switch. Horns, bells, and speakers may be used to sound a general alarm. In some situations, an alarm may sound only a few floors or in a specific location. When the alarm sounds, occupants should respond immediately and evacuate the building. Trouble signals sound when there is a problem with the system's integrity. It typically is a constant tone, beep, or buzz, accompanied by a visible light on the panel. Trouble signals are not alarms, but sometimes improper monitoring by personnel will initiate a fire department response. System problems should always be investigated and resolved as soon as possible because they can prevent the action of the alarm. Supervisory singles sound when there is a change in the normal ready status of the fire protection system or device that are connected to control panels. In many buildings, the control panel electronically monitors some of the following systems: sprinklers, control valves, dry pipe sprinkler systems and air pressures, fire pump status, air temperature of a sprinkler system valve room, or a water temperature level and pressure in a storage tank, and duct and smoke detector operations. By electronically supervising the valve, an immediate investigation can be initiated if there's a problem. The signal will use the same constant tone and light as the trouble signal. It is not an alarm signal, and fire department response should not be necessary. Any supervisor signal should be investigated in a timely manner and should be followed up with and investigated by a qualified service technician. Let's look at initiating devices now. Initiating devices interface with the fire control panel to manually or automatically activate the fire alarm or supervisory signals. Manual initiation devices. The manual fire alarm box is the only type of manual alarm initiating device. It has many different names: manual box, manual pull box, and manual pull stations, to name a few. It requires a person to pull a handle to activate the alarm. It must be accessible, visible, and consistently located for ease of occupant and visitor use. Not all manual fire alarm boxes are linked to the fire department. If not, there must be a placard instructing notification of the fire department. NFPA 72, the National Fire Alarm and Signal Code, lists the requirements for manual fire alarm boxes. They must be located within 5 feet of an exit. They must be mounted between 42 and 48 inches above the floor. Must be located on each side of an exit opening greater than 40 feet wide. And it must be located within every 200 feet of travel distance. If the distance is greater than 200 feet, additional boxes are required. They should be red unless the environment precludes the use of this color. In those cases, use an alternate material that makes the box conspicuous. If conditions are moist, damp, or wet, the box must be listed or approved for these conditions. It must be protected to avoid corrosion, rust, electrical shorting, and grounding. Protective covers serve multiple purposes. 1, they protect them from the environment. 2, they protect from damage, such as in a gymnasium. They deter individuals from pulling the box to create a false alarm. When the cover is listed, a local siren should sound. Some individuals might think that the siren has initiated the fire alarm system, so training is required for proper use. So let's look at some operational characteristics. All boxes operated by pulling a lever, but there may be additional operation characteristics, and these put them in a different category. Non-coded, an alarm is initiated until it is reset. You may have some that are coded. A code sounds from an audible notification device when a monitor turns a wheel. A person can determine which box is operated by counting the code that is sounding and determine the location of the box. General alarm. An alarm is immediate and initiated throughout the structure. You can have pre-signal, which is signal is sent to the location where the boxes are constantly monitored. The alarm is initiated from there. You also have the break glass. A glass rod or other breakable material must be broken before the lever can be pulled. You have non-breaking glass, a non-material that must be broken to initiate. You have single action and double action. The single action, there's only one action, such as pulling a lever. The double action, there are two actions, such as opening a cover and pulling a lever to activate the alarm. Once a fire alarm box is pulled, it requires resetting. The fire alarm system will usually not reset until it is back to a normal or ready service. Usually the box must be opened, often with some sort of special key or tool, and then a switch may be needed to reset or a rod may need to be replaced. Oftentimes you can find these components somewhere near the control panel or sprinkler head box. Automatic initiating devices. Automatic fire detectors are classified by the fire signature component they detect, such as heat, smoke, flame, or gas. Each class operates differently, and one may be more appropriate than another for a particular hazard area. Automatic fire detectors are also classified by the class and size of the hazards they protect. Spot detectors cover a specific area or a location. You have line detectors that cover areas along an uninterrupted linear route, such as probably a warehouse. You also have air sampling smoke detectors that pull air from a protected area into a unit that analyzes the air and checks for the products of combustion. Heat detectors are one of the most common, and here are some general characteristics. It is installed when environment conditions and temperatures fluctuate, where heat output of a fire will be high, or where the speed of fire detection is not a concern. They are not prone to false alarm, and they're very inexpensive. They are slower, however, to detect fire because they rely on heat detection and not smoke, and are usually not considered life safety devices. The type of fuel hazard and its associated rate of fire development determines which type of heat detector is installed. Fixed temperature heat detectors operate when a sensing element within the detector reaches a predetermined level. Some use fusible links, sensing elements that melt when the predetermined temperature is met. Often used sensing element, which closes when exposed to increasing temperature, sending a signal to the fire alarm panel. These are usually spot detectors, but they can also be line detectors or detectors with electrical resistant components. Thermal lags must be taken into account with these detectors by choosing the correct temperature rating so that the fire detection is timely. Radarized heat detectors use pneumatic or electrical methods to monitor how much temperature change occurs over a fixed amount of time. When the rate exceeds the fixed amount, the signal transmits to the fire alarm control panel. These detectors can be line or spot detectors, both of which use rubber diaphragms to initiate an alarm. Diaphragms heat to close the electronic rate of rise detector. When the detector temperature changes through a thermistor, these devices detect temperatures more quickly than fixed temperature detectors and may not be appropriate where normal ambient conditions dictate rates of temperature change that could cause false alarm. These are usually restorable after a fire, but may need to cool down before being reset. Fixed temperature radarized heat detectors combine the operational characteristics of two into one. Whether a fire develops slowly or quickly, the detector can detect it and send a signal to the fire alarm panel. If the fixed temperature portion activates, the detector must be replaced. Finally, we have rate-compensated heat detectors, responded to predetermined air temperatures. They are not dependent on rate of temperature change. They are usually tubular and use two-element sensing systems. Two components for slow or fast temperature change. The sensing elements are made with metal designed to expand at different rates. Once that metal expands, then the system connects and the alarm will go off. This method compensates for that thermal lag, and they are restorable. Smoke detectors. Here's some general characteristics. They rely on smoke particles emanating from a fire rather than heat generation. Smoke is developed and detected faster than heat. These detectors are considered life safety devices because most deaths are caused by inhalation of smoke or toxic gases. They do have some limitations, however. They can only cover a small area reliably and must be appropriately sensitive for their environment to avoid false alarms or delayed fire detection. They are only as good as the level of inspection, maintenance, and testing done. Detector selection is based on a number of factors, such as environmental conditions, construction and design issues, building content, ceiling shape, height, and surface. Ventilation and airflow burning characteristics of the combustible material may also affect them. The correct type and locations are critical to provide a quick response, ensuring life safety. Light scattered photoelectric smoke detectors are spot detectors that use a light source and receiver to initiate an alarm. The light and receiver are installed in the sensing chamber at an angle to each other. If smoke enters the sensing chamber, the light refracts onto the receiver and initiates an alarm. These detectors respond most quickly to smoldering fires, which generate large smoke particles that refract sufficient light for detection. Light-obscured photoelectric smoke detectors, also known as beam detectors, project a beam of light to a receiver that spans a protected area, setting an alarm off when the receiver senses a reduction in the light intensity. The protection range can exceed 300 feet long by 60 feet wide. This detector is common in locations where ceilings are very high, such as atriums or factories. The detector must mount on a stable wall or ceiling surface so that movement or vibration do not misalign the beam. Only well-placed beam detectors can replace multiple spot detectors. Air sampling smoke detectors, also known as aspirating detection, are sophisticated systems designed to draw air from the protected area into the chamber for analysis. The system is capable of detecting unseen byproducts that form the pre-combustion stage long before an occupant would notice. Continuous air sampling smoke detection draws air through piping, past filters, and removes dust, and into a detector that uses a light source and receptor to measure the reflected light. Different levels of alarm communicate how much smoke is present. A cloud chamber type detection creates an environment within the detector chamber where condensation forms on smoke particles, causing them to increase and eventually initiate alarm when they exceed a predetermined size. Spot type detection uses filtered photoelectric detection with air sampling technology in a spot detector or in environments where the dust level is higher than normal. These detectors are not suited for outdoor or potential explosive environments. Many air sampling systems are installed as stand-alone systems to protect a critical operational area of a building, but they can also be used with fire suppression systems. Their earlier detection helps protect against unintended discharge of suppression agents. Air supply systems are installed where concealed detection is important. Maintenance access is limited or critical processes cannot be disturbed, such as historical buildings, production facilities, and textile mills. Right? Another system. Duct smoke detections are used to shut down commercial air distributing systems that can move large amounts of air throughout a building in a short period of time, spreading the smoke and toxic gases all over. Duct system detectors are not early warning detectors. Some are mounted inside the ductwork while others are outside and attached to air sampling tubes in the ductwork. They can be hard to see from floor level, so their location must be documented and clearly identified. NFPA 72 requires some to have remote indicators. Adequate access to these detectors for maintenance and replacement post-incident is necessary to avoid false alarms or to perform manual resets if there is no remote. Some sound an alarm while others sound a supervisor or signal depending on the level of acceptable risk. Not all air distribution systems require these detectors. It depends on the system capabilities. These detectors require a list of approval for the use of expected conditions. They must be able to operate in varying conditions. Another system is a video, smoke, and flame detector, which uses high-definition video cameras to detect smoke and flame. The technology analyzes the digital images and detects changes in the pixels before there is enough smoke to detect it visually. This allows for rapid detection. Video feeds also help first responders view the area before entering. Also, you have a multiple parameter, low false alarm, fire detection analysts and components, and the physical chemical components detect gas and materials against profiles of real components. The goal here is to increase the system's reliability and decrease false alarms. They were introduced in 2005. The system digitizes and processes multiple sensor readings that are then compared to the readings with the chemical indicators of fire. These systems also use MEMS-based particular textures and classifiers devices to increase chemical measurement reliability. The system protects difficult-to-reach locations such as storage depots, cargo bays, and aircraft. Radiant energy sensing fire detectors, also known as flame and spark ember detectors. These detectors look for specific portions of the visible and invisible light spectrum produced by flames, sparks, and embers. They are not dependent on smoke or heat plumes. They are used in many environments, but especially in industrial and manufacturing environments. Exposure to non-fire related sources of radiant energy is greater. They are usually installed where the hazard level is high. Rapid and sensitive detection is critical, and remote detection of small fires is crucial in such places as petroleum processing, storage, and loading facilities. The right type of detector is based on the environment and fuel type, as well as the source of non-fire radiant energy that could cause false alarms or missing alarms in true emergencies. Flame detectors are designated by the part of the light spectrum they detect, such as ultraviolet, infrared, ultraviolet infrared, and infrared and infrared. UV-IR and IR-IR types have two sensing components. This improves fire detection and reduces susceptibility to non-fire radiant energy sources. Detectors must have an unobstructed view of a protected area and be close enough to detect energy. Additional detectors are required if this is not possible. Flame detectors work in a specific environment with specific fuels. Spark and ember detectors are not fuel specific. They are installed on or near equipment where material moves through a duct line or a conveyor belt. They operate in the IR range and must be installed in a closed, dark environment. When they detect a spark or ember, a single operates suppression equipment. Gas sensing fire detectors. They utilize multiple sensing technologies, such as infrared, semiconductors, electrochemical, and catalytic bead. They detect gas and vapors associated with a process that uses hydrocarbons. They protect high hazard environments like offshore oil and gas rigs and HVAC air intakes. Single processing and alarm verification. Most modern fire alarm and smoke detectors are able to validate a smoke condition before sounding an alarm. Single process checks the smoke in the detectors in specific intervals to ensure it remains above a threshold. If it remains above the threshold for a certain amount of time, an alarm is initiated. When alarm verification and when the fire alarm panel receives a signal, it allows a minute for the condition to clear before sounding an alarm. It is beneficial where nuisance alarms are common, such as dormitories or areas with toaster ovens. NFPA 72 lists alarm verification requirements, such as allowable alarm delays and automatic alarm overrides. This method is prohibitive if more than one smoke detector is required to actuate an alarm, as in computer rooms. Water flow initiation devices, also known as a water flow switch. This device uses a flexible round plastic paddle or vane that is inserted into the wet sprinkler system piping. When sustained water moves through the piping, the paddle moves and activates the switch. The switch sends a signal to the panel and it activates the fire alarm. When water stops flowing, the switch returns to its normal position. The fire alarm system is reset at the panel. It is installed by the sprinkler contractor but wired to the fire alarm system by a fire alarm or electrical contractor. An arrow on the frame points in the direction of the water that it will flow. There may be one or multiple water flow switches. There are different switches for different pipes. Installing the wrong kind causes leaks and malfunctions. The paddle size must also be correct to ensure that its activation correctly and does not block water flow or hold the switch in a constant alarm position. The switch has a built-in adjustable time delay to compensate for fluctuations in water pressure. It is usually pneumatic and can be set for no delay or delaying up to 90 seconds. Often, though, 30 to 60 seconds is typical when setting the alarm. An alarm pressure switch initiation device. The alarm pressure switch is installed by the fire sprinkler contractor and wired by the fire alarm or electrical contractor as well. Most pressure switches screw into a fitting that is part of the pipe component packing or the sprinkler system. They operate when the pressure setting rises above or drops below the preset threshold. Many use a diaphragm and spring to detect pressure changes. Some use a mercury switch. They do not have a time delay mechanism, however. When they reach the threshold, the alarm signal is sent to the alarm panel. The switch may require manual reset. This type of switch is best for dry pipe, pre-actionary, and deluge systems, wet sprinkler systems with recharge chambers, and other types of water-based fire protection systems. Notification of occupants is the most important function of the fire alarm system. After the initiation device signals the fire control panel, a notification appliance produces some sort of audible and visible signal to prompt evacuation, relocation of occupants, and in some cases reports system problems. Many different notification appliances are used. Devices include bells, horns, speakers, chimes, buzzers, sirens, strobe lights, lamps, and a combination of all the previous mentioned devices. Loudness and brightness are established by adopted codes and standards. System types and devices location depend on multiple factors, such as code requirements, the environment, the occupancy conditions, and how much information needs to be conveyed and to whom. Public mode / private mode notifications. A primary consideration is whether the alarm should alert the public or send a signal to a monitoring location where it can be interpreted by trained personnel. A public mode notification that alerts occupants visually or audibly is the most common. It is most appropriate for locations where people can make decisions and take actions during an evacuation, such as grocery stores, schools, or office buildings. The alarm devices are seen and heard throughout the building. A private mode notification is used when sounding general alarm is impractical. It is appropriate when occupants are not physically or mentally capable, or when their movement is restricted, such as nursing homes, hospitals, and jails. Trained individuals receive the signal and then implement appropriate emergency procedures. Coded, non-coded, and textual signals. Coded signals generate a predetermined number of visual or audible parameters for a specific duration to identify the location of the initiating device. The initiating device is assigned a code and can be located by counting the code sounding from the audible appliance. Non-coded signals provide a constant visual or audible signal that remains active until it is reset. Textual signals may be a voice message heard from a loudspeaker, a text message on an annunciator panel, or a symbol flashing on a computer screen. Audible appliances and audible devices must be loud enough to be heard above the normal noise level of the area. NFPA 72 establishes audible sound level requirements for occupied areas. It regulates the duration in decibels for various scenarios. Audible devices must also make a distinctive sound to avoid confusion with other signals, including those generated by the fire alarm system. An EPA requires an evacuation signal to be in accordance with ANSI 3.41, the American National Standard Audible Evacuation Signal, which is 3 pulse temporal pattern. Repeats for as long as it takes to evacuate the building, no less than 180 seconds. Although model code requires the temporal pattern for new construction, it can be hard to ensure that the entire building system is upgraded. In buildings that have undergone partial and entire floor renovations, there may be different audible appliances that produce different sounds. Many jurisdictions requires a floor to have the same type of device throughout to avoid confusion. Audible devices must relay information intelligibly. The voice signal is loud enough, but the information is not clear and understandable. Then the information is useless. The quality or age of the system components can be a problem. Lack of synchronization of audible devices can also be a problem. NFPA 72 states that emergency voice alarm communication systems must reproduce messages with voice intelligibility. Digital, audio, and proper evaluation of architectural building characteristics should allow a system designer to deliver the required specifications. Horns are one of the most common installed audible appliances in non-high-rise buildings. The sound is loud, piercing, and very distinctive. Horns mount on walls or ceilings. They may be installed as necessary and can be semi-recessed on surface mounts. Horns may sound constantly, sound a specific code signal, or sound a 3 pulsing temporal pattern. Speakers, the most versatile audible notification appliance because they can reproduce many different sounds in singles. They are mainly used in high-rise systems and sound the 3 pulsing temporal pattern, a pre-recorded voice message, or a live voice message. Digital technology has eliminated the need for tape players and other outdated technology subject to mechanical failure. Speakers are usually ceiling mounted and driven by a remote source, and amplification equipment or integrated source and amplification equipment. Bells. Most early systems used bells to sound the fire alarm, and many are still in use today. Some early systems also used small bells for trouble and supervisory signals. A bell can be used as long as it is distinguishable or known by the occupants as the sound of the fire alarm. Bells are wall-mounted with a striking mechanism located underneath a domed cover. Some strike continuously, others make single strokes to provide a coded signal. Bells come in different sizes and produce a signal that can travel an entire audible range. They are good for people with mild to moderate hearing loss. New installations, however, are less frequent. A more distinctive and louder sound is desirable. Chimes, buzzers, and sirens. Chimes have a gentle, soothing tone and are used where other notification appliances might startle occupants. These are appropriate for hospitals, nursing homes, and possible correctional institutions. Buzzers are rarely used as a general fire signal. They are more likely to be used as an audible indicator of system trouble or a supervisory condition. The irritating sound a buzzer may cause people to silence it without fixing the problem. So newer systems have an indication lamp that stay on as a reminder of the problem. Sirens are more suitable as notification devices outside or in a very loud environment. They might be mounted on a building exterior to notify building personnel or assist fire persons who are trying to locate the origin of a signal. They can be found inside where there is constant loud noise, such as a bottling plant. Piezo's or mini horns are commonly installed where a small, unobstructive yet coded compliant notification device is wanted. They are appropriate for hotels, motels, apartments, and other residential occupancies where aesthetics are considered very important. Even though they are small, they can produce loud output levels and have different tones and sound options. Finally, exit-marked audible notification appliances. These systems were developed to help move people to safely quickly. They use tone and intents that are different from conventional notification appliances to guide people to the nearest exit or place of refuge during an emergency. Visible appliances. They produce the flashing lights that are seen when a fire alarm system is activated. They are necessary where people within an occupancy will not hear the audible alarm. And there is high ambient noise levels. Persons with disabilities such as hearing loss or deafness are also a possibility. They are required by adopted building, fire, accessibility, and life safety codes. They are to be installed in public and common areas, employee work areas, high ambient noise level areas, and commercial and industrial properties, sleeping rooms for handicapped persons, in institutional and residential occupancies. They require number, location, type, intensity, and size depending on the size and shape of the protected area or room. When operating in public mode, the goal is for the appliance to be visible no matter where a person is in the protected area. It must be installed on the wall between 80 and 96 inches above finished floor or on the ceiling, with no more than 30 feet above the finished floor. The light source must be clear and nominal white. The light intensity must not exceed 1,000 candles. If there are two or more, they must flash at the same synchronized rate. Strobe lights are most commonly used. They provide a constant, short, bright flash. They attract attention like a camera bulb. Other options include quartz, halogen lamps, solid-state lamps, fluorescent lamps, and incandescent lamps. Quartz lamps provide a high-intensity light output and are well suited for the outdoors. Solid-state lamps are reliable and found on Annunciation Panels. Fluorescent lamps illuminate signs or messages when a constant light source is appropriate. Not used for coded or flashing appliances because they have a low intensity output and do not light immediately. Incandescent lamps are available for coded and non-coded appliances, but burn out quickly and require more frequent replacement than any other kind. Combination appliances. Audible and visible devices are commonly combined so that sound and visible light originate from a single appliance. They include horns, strobes, speakers and strobes, bells and flashing, incandescent lamp combination devices. They provide the audible and light intensity needed to cover an area with a single device. They give a visible signal when the audible component cannot be heard and help identify an audible device that is sounding outside a cluster of buildings. This relatively new appliance can interact via software with the microprocessor-based fire alarm control panel to perform multiple functions. They can program candle rating, determine the adjustable available power levels, perform tests, and print status reports. This technology saves time and money because when there is a problem, the alarm panel communicates precise information so the issue can be detected and fixed. Annunciation panels. After responding to the main entrance and initiating operation activities, firefighters look for the annunciation panel. This notification or indication device provides valuable information, such as the initiating device, the systems involved, or the area of the building where the fire is located. Some panels are simple with handwritten information, while others have LCD textual messaging or touchscreen computer technology to relay information to the firefighters. Some annunciation panels provide a graphic representation of a building footprint. Backlights or bull's-eye lamps show staircases, critical areas in the building, zone areas, floor levels, and device identification. Different colored lights, lenses, or light-emitting diodes identify the type of signal being generated by the initiating device. Green or white lights indicate a power signal. Amber, yellow, or orange light indicate trouble or supervisory signal. Other panel features include system reset, alarm silence, alarm acknowledgement, alarm testing, and status indication for other systems. Access and critical system control features to assist first responders. More sophisticated panels can further define the initiating device's location. The panel may also have system status indicators and control switches. These allow firefighters to start critical building equipment such as fire pumps, generators, stairway doors, or smoke control systems. Graphic annunciating panels. The graphic type annunciating panel offers information about building layout, fire protection systems, and related information. They provide immediate visual information, displaying the building footprint, zones, exit stair locations, elevator locations, critical rooms, areas, and device type and location. They display various locations such as building address, you are here indicators, FEC connections, and entrances. The information must be up to date and accurate. Many graphic panels are manufactured, so updating information takes time. In some situations, it is acceptable to mount a protected diagram next to the panel. It is easier and more cost-effective to provide the graphic display than to remove and disable the annunciation panel for updating. The computer touchscreen. This is the most advanced type of annunciation system. It provides information about the status of the building fire protection systems and it's integrated with other building systems. This gives first responders important access to help determine operational strategies. Power expander panels. When buildings are renovated, often it is discovered that existing control panels are not sufficient to support additional required audible and visual notification devices. Modern appliances use significant electricity, so it may not be practical to place all power and circuits in the panel. There may also be design issues related to expansion or power distribution, such as space, location, and accessibility. Installation of power expander panels. Power expander panels can provide supplemental power to support devices. They are not the same as a fire alarm control panel. They can monitor the integrity of notification appliances and circuits, but they do not have any control functions. Because they act in conjunction with the main panel's power supply, they must have a primary and secondary power source. Power expander panels may be located in utility closets, on the floor of the building, where there is a need for additional power, depending on number and location of the audio and visual notification devices required for the system. Okay, let's look at everything else now. Electronic valve supervisory devices. Electronic supervision of control valves is important because one valve in the wrong position could put an entire fire suppression system out of service. Tamper switches send a supervisor signal to the fire alarm panel to alert personnel of abnormal conditions within the control valve. The tamper switch may be built into the control valve or attached to an external device. A signal is sent to the control panel when the valve travels. To reset the switch and fire alarm system, the valve must be returned to its normal position. Pressure switches. In addition to initiating an alarm signal, a pressure switch can generate a supervisory signal. Monitor system parameters when installed on a dry pipe, preactionary, and pressure tank system. When the air pressure in a dry system drops below a minimum threshold, the pressure switch will signal a supervisory alarm condition. If the compressor causes the system to exceed maximum pressure, the same switch will signal the supervisory alarm. Finally, air and water temperature sensors. Air and water temperature sensors provide a way to monitor the temperature and condition in the room that house the fire protection equipment and the water used for the fire protection devices. If the temperature falls below a certain threshold, a supervisory signal is sent to the monitoring facility. Water level sensors may monitor the amount of water in the storage tank. If the water level falls below a certain threshold, a supervisory signal is sent to the monitoring facility. Okay, let's sum up this chapter. I know there's a lot of information in it. My advice to you is write down each type of system and know some characteristics about each and how they differ and what they protect. One of the most important functions of the fire alarm system is to notify building occupants that there is a fire condition. The fire alarm system is also capable of sending different signals to an on or off-site location where trained staff take the appropriate action. Over the past 40 or so years, fire alarm control panel technology has evolved from very simple to very complex. The most sophisticated and newest systems use microprocessor-based software-driven systems that interface with the building and life safety systems. Some fire alarm systems have the capability of sending signals to other building systems to perform life safety functions, such as capturing elevators, recalling elevators to a particular floor, turning off the power to elevators, unlocking exit doors, starting fans, closing smoke dampers, and pressurizing stair towers and elevator shafts, and closing smoke doors to compartmentalize an area of the building. The fire alarm system provides critical information to first responders by identifying alarm type and location. Any supervising other fire and life safety systems and components. Many different components are necessary to ensure fully system functionality and operational capability during a fire and emergency. Fire alarm panels monitor and control All system devices initiate the appropriate type of signal, which include alarm, trouble, or supervisory. Initiating devices provide manual or automatic means of activating fire alarms and supervisory signals. Finally, notification appliances provide audible, visual, and textual signals to begin evacuation or relocation of occupancies. The Annunciation Panel provides visible and valuable information concerning the device signal and alarm in the area of the building where the fire is located. Okay. Now, if you have any questions, feel free to contact me at aroberts@athenstech.edu, or you can reach me in my office at 706-357-0162. Also, check the calendar in Blackboard to see when I will be available for virtual office hours in Blackboard Collaborate Ultra if you have any questions or concerns that you would like real-time interaction. Thank you very much and have a great day.